Hello friends, in my last video I had demoed an LLM analytics assistant connected to a AWS and Azure data warehouse on the backend and allowing a user to run queries, data transformation and analysis using natural language. And I had shared a full guide on how to build one code's GitHub repo, step-by-step process, everything. In this video I'll demo a custom GPT doing the same thing, in fact in a voice mode as well as in a multilingual mode, connected to the same data warehouse uh, and doing the same thing. Now I have a fast API server in the middle that makes switching front ends and data connections very simple. Now this video will also show the power of custom actions in a custom GPT that allows a custom GPT to connect for a two-way data transfer to any data warehouse or any resource outside, just with a simple API call. Now I'll again share the complete how to build codes, step-by-step process, everything, nothing held back. So I have a prototype warehouse. One is on AWS RDS MySQL, and the other one is on Azure, again MySQL. The AWS warehouse has got record size ranging from 10 records to 10 million records. I'll go to the custom GPT and then open that in the voice mode. So Bank 10K add a new field called response tag. Response tag is equal to 1 wherever response is equal to yes. Go ahead.
New field response tag has been added to the Bank 10K table and updated to 1 wherever the response is equal to yes.
Now I want to look at the trend by age, but that age is a continuous variable. So can you look at that distribution, do a bucketing, and then share the response rate by age buckets?
I have displayed the response rates by age buckets for you. The data shows.
So now you have response rates by age bucket, marital status, and education. So can you combine these response rates, these three things, into some kind of insightful, nice chart?
Here is the chart displaying the response rates by education, marital status, and age buckets. It provides a visual comparison.
एक समरी बनाओ टेबल फॉर्मेट में, बैलेंस का टोटल, रिकॉर्ड का काउंट, और वो डिफ़ॉल्ट में यस का काउंट, वो एजुकेशन के हिसाब से ग्रुप कर दो, टोटल लाइन भी डाल दो और तीनों का परसेंटेज ऑफ टोटल भी दिखा दो. अभी एक आध बढ़िया सा चकाचक चार्ट दिखाओ. बढ़िया है. एक और काम करो, वो AWS में डेफ 10 टेबल का कॉपी मार के अजूर में घुसा दो, अजूर में डाल दो. Look at how we can do this, or rather how I have been doing this. There are numerous ways of doing this, so I am sharing the one which is specific for my use case, but I do believe it has broader applicability for many use cases. So we start with the user and the user interface. So any user interface, it can be through a custom GPT, it can be a front end built with tools like Flowise, VectorShift, or any of the other numerous LLM platforms. Now each platform or a tooling has its own pros, cons, pricing and considerations. Alternatively, it can be built completely custom built using React, JavaScript, PHP, and then create the right API call, or rather the parameters to be passed for the API call. That's what all that it does. It creates the SQL query, which is actually the parameter. Now after that, the tool itself, it makes the API call. Now that's pretty much standard HTTP fetch request, standard HTTP fetch request that the IT world has been doing for decades, and that call can be made by whichever tool, whichever language you are using. Now specifically in my setup, the query now goes to a fast API server. That's the next part of it. Now, since I am comfortable in the Python environment, I found Fast API to be an easy and a quick way to deploy a processing server. So that's what I tend to do for my use cases now. I understand the Python code also a little more easier. However, this is the only option. There are many others. You can use a standard REST APIs, but I find them to be a bit tougher, honestly. In any case, all the coding is done by GPT based on my instruction, but it does take some iteration. Sometimes you need to check the code yourself, where GPT gets stuck to get it working properly in a live environment. A lot of testing is required. Now, I have kept this processing server as an API endpoint and separate from the main system. I can directly, potentially, I could have connected the LLM app Flowise directly to a database server also. There are many ways to do it. So I have kept this processing server as an API endpoint and separate from the main system. While you could potentially connect the LLM app directly to the data warehouse without this middle hop, I choose to keep it separately for reusability, right? Now this allows me to connect the middle processing layer to any UI app. The client might want to do it via Custom GPT or Flowise or some other way, and the backend database could be anything. So this makes it very reusable. And all that I need to do is change the DB connection and point to the new API endpoint URL. So that's the way I've gone about it. The code itself is a short, simple Python code. GPT coded it. All it does, it takes the incoming query, establishes a connection with the database, sends the query to the database, receives the response back, and then sends the response back to the whoever is making the API front end, that is making the API call. For my response, this one I use a pipe delimited format, but it can be any format, CSV, JSON, or even an object can be passed along, like file, image, video file. Again, the IT world has been doing this for decades. Then the database, it can be Azure. In my case, I have connected it to Azure and AWS. It can be anything. It receives the query, processes it, and then sends back the response, and the fast API server catches the response, then hands it over back to the UI front end. Back to that LLM app. Now the LLM app or your front end, then that it receives the LLM input, it formats. It could be receiving that in pipe delimited format, as in my case. Then it has to format the input appropriately. So in my case, it comes in a like I said, pipe delimited format, and then whichever format the user has requested for, or whatever is the appropriate for that response, the LLM sort of serves it that way. Now here is one important point in this whole framework and thing. The top part, that is the newer part, right? That is the whole breakthrough part, right? Where the LLM model now is able to convert a natural language in a natural language into a SQL query or an API parameter. That's a huge big part, and there are a bunch of considerations there. Accuracy of the query. How do we make sure that the query is accurate? You can use a simple LLM model, or you can use an agentic framework, with a supervisor worker setup, or many other setups are possible. Now, the rest of the remaining framework that you see there, that all that framework are just API calls, essentially. It is the HTTP fetch request. That is something the IT world has been doing for ages. The entire internet backbone is built on this two-way flow of information through API call, passing through text, data, objects, everything. All the apps that we use, the desktop and the web app, is based on, that's the framework. Large proportion it is on the REST API framework, I believe. So this is the GitHub repo. It's public, so you can pick up all the codes from here. The main files are app.py and requirements.txt. Is the same one which I have shared, explained in the guide. For making modification, I use GitHub Codespaces, but you can use any of your favorite tools or editor. Make the changes, commit them, push them, and you are good to go. Set up your own database configuration parameter, which will need to be modified. Here I've exposed them in the code for explanation purposes, but best to keep them in an environment variables as I have mentioned in the guide. Next step is to go to render for deployment. Choose a new web service. It's a straightforward process. Point to the GitHub repo and connect it. And once connected, we get all these options. For most of the cases, the default options will work. For the start command, we need to use the 𝗶𝗃𝗀𝗁 start, which I've shared in the guide, shown here also. Choose your plans, free service, free or starters, advanced options if required, and just hit deploy. It takes a few minutes and the web service will be shown as live, and that gives us the API endpoint URL here on the top. So that's the same API endpoint URL that I refer to in the guide, which will need to be updated in the next step. So we start creating a new GPT and we go to configure tab. We fill in all the details. This is the details which I have used. I have also shared in the guide the custom instructions which need to be filled in for this. Then we need to create a new action. So we go to create new action, and there we need to fill in the action schema, which we can get done from either our regular GPT-4o or the GPT action builder or the action GPT from custom from OpenAI itself. And this is what the prompt look like. So I have shared this all of this in the guide. You can copy from there and replace with your information. We share what we want to do, and important part is the OpenAPI schema, which is auto generated. So for this we need to go to our API endpoint and suffix it with OpenAPI.json, and it gives us the actual schema for our endpoint, which we paste here. We add the other details like the URL, the endpoint for it. We share a sample API call, what it looks like, and we put all this prompt into Custom GPT and or GPT-4o, and we get the OpenAPI schema. So this one, then we go ahead and copy this schema into the function areas, and once we put that into the function area, we say we can test it, and here I am asking it to share the tables in the AWS warehouse, and it will ask me whether to ask for permission, which I will say yes, and once I give the permission, it makes the HTTP request as per the function, and now this shows the tables, which means we are connected. So now let's break down what is happening in the custom function OpenAPI schema, what all of these each of these items mean there. So whenever a custom GPT has to connect to an outside resource, it can do so via custom function that can make an API call to an API endpoint. So pretty much any resource, whether it is a database or anything on the website or anything that has an API endpoint, custom GPT can connect to it for a two-way transfer of information. And any custom processing that you might want to do, you can deploy that as an API endpoint and have custom GPT connect to it. I have shared how to develop and deploy a custom endpoint for this particular processing in earlier sections. A similar framework can be used for pretty much any kind of processing that you might want to do, whether it is related to Python or machine learning or statistical analysis or pretty much anything. APIs are the backbone of the internet. They have been there for long. The IT world has been doing it for ages. We are now just connecting the Open API has given us the facility to connect it to any API, which is a very, very powerful function or a very, very powerful capability. So this is the Open API schema that we get. I have also shared this in the detailed video guide. So this has the Open API version. This has the descriptions, what we have, and this URL is the endpoint URL that we have deployed on render. So you'll have to replace it with that render URL. That's it. And then this is the part that in that URL, then this is the API actual endpoint. Method is HTTP request will be made using the get method. description is there, and then these are the parameters, that these are the parameters to be passed. There are two parameters, one is SQL query and second is the cloud. SQL query parameter is the actual SQL query. So LLM is supposed to generate this SQL query based on natural language, and it will pass it as a parameter, and it will be passed as a parameter in the query as in the part of the URL. Required is true, this is always required, and this is type string. Second parameter is cloud, whether it is AWS or Azure. So depending on what the user has mentioned, this is also required true, and it can either take the value AWS or Azure in small, and this will also be passed as part of the OpenAPI, part of the API call. So this is what the LLM does. It comes, it provides the LLM tool agent will execute this API call, and the LLM will provide it with these details, and it will formulate the URL, API URL, and execute that. And the rest of them is standard stuff like 200 is response successfully received, and if it is a validation error, then give so and so messages and so on. So that this is all that is happening in the function call. What is the API URL, the endpoint, what parameters it should have, and if there are restrictions, and if we add descriptions and so on to help with the API call.